Hi everyone. So in today's video, what I would like to do is to take you through the entire process of writing a recipe and the associated diagnostic. So you will see the whole process and how I'm doing it, like using Getty. So this is probably going to be a bit fast again, so don't hesitate to pause the video and go back when needed. So hopefully in the process we will get to discuss some interesting aspects of ESMValTool and how the tool works. Alright, so the way I'm doing this, and again, just to quickly mention that there's a tutorial available online, so I will go through some aspects of how you write a diagnostic and a recipe, but doing it in a kind of a quick and dirty way, if you want. So just to fit the idea of a short tutorial. All right. So the way I do development is I use Visual Studio Code. So I'm going to start Visual Studio Code here. Here we go. And so Visual Studio has some interesting extension to do SSH connection. So you can use, I'm going to use remote SSH. I'm not going to go through how I've configured it, but basically it'll give you the option to open a remote window here and connect to a host. So I've got Getty available already. And if I go to the File Explorer here, I can open a folder on Getty, so a remote folder. So what we're going to do today is we're going to work on Scratch. So TM70 is the ACCESS-NRI project, so use your own, please. And I'm going to go to a folder called ESMValTool. Here we go. Just going to close this one, open a terminal so that we have a nice terminal at the bottom of our screen so that we can, I'm just going to make this a bit bigger, and we should be all set. So that gives me a terminal. I can look around and what I can do here. I've prepared the output, the PNG output of what we're going to do today, and so I'm going to show you. So VS Code gives you also the option to open images. So this is basically what we're going to try to reproduce today from scratch. So a map of Australia with surface air temperature controlled only on the land. So using a mask, and so there are obviously many ways to do this. I'm going to show you one way. So don't get. I mean, you may have a different way of doing things. So feel free to comment and do things your way. Okay, so let's clear this, and I'm gonna move that image to folder. Go. So let's create a folder called tutorial. So it should appear in my File Explorer on the side. You could also use the GUI if you want. That's obviously an option, right? Okay, and let's see what's next. So so to write a recipe, what you need is obviously a recipe YAML file. So I've discussed the format in the previous video, or if you haven't seen it, like don't hesitate to have a look. So we're just gonna create a file called recipe australia.yml. We go, and I'm gonna create diagnostics that is called australia.py, so a Python diagnostic. This is still showing here. This is in the wrong folder, so I'm just gonna move things in the right folder. Here we go. So let's try. Let's start by writing our recipe. So, and I'll go through the different things we need to do there. Let's just make this a little bit bigger again. Okay, so first two lines. It's always good to start saying that it's an ESMValTool file, and we call it recipe australia.yml. Right, so we've got a nice header now. So you need like some high-level sections. The first one is the documentation. The next one is the datasets. Then we need some preprocessors, and finally we're going to need some diagnostics. Okay, right, so these are my different sections. Just gonna put a bit of space between them. That's the minimum needed. Okay, so that, but if you run that recipe now, it's gonna fail because it cannot find information around documentation. But this is the start of our structure. So let's keep going. We're gonna add some description about what we want to do. Australia map temperature anomaly, for example. We need a title. Australia, so nothing very fancy here. Australia temperature anomalies. Let's add some offers. So I'm going to put myself, de chez Romain, maintainers, myself as well. We could have a project. So we have if you use Gadi, there's a project called ACCESS-NRI. The important point here is to understand that offers, maintainer, and project actually refer to keywords that are in the ESMValTool reference database. So it needs to be added. So if your name is probably not there, we could add it if you like. Or the easiest is probably just to use a name that's already there. So use mine or someone from the ESMValTool team. All right, so now we've got our documentation. So the interesting thing we can do is actually we can try to test things live. By creating by opening an interactive job on Getty. So what I can do is I can submit a request to PBS. So let's write a job PBS file with some resources request. So what are we gonna do? So let's write our script live. So this is a bash script. Ship online. Using the IQ82 compute project. Again, this is an ACCESS-NRI specific project, so use your own. And so I'm gonna request some mounts, XP65, because that's where ESMValTool is installed, and I'm gonna request access to the CMIP6 data collection. So GData, FS38, OI10, and what I like to add to is CT11, which is the ACCESS-NRI collection for, replica for of observational datasets for model evaluation. That's a flag for, to use the working directory. We can ask a queue, normal queue will be fine, I believe. Or let's ask copy queue just in case we need access to the internet. PBS wall time of 4 hours should be more than enough. And we need to request some actual resources, so which is some memory. So let's do 32 gigabyte is more than enough. Actually, let's do 16 gigabyte. We no need to ask for more. And just one CPU. That's okay. Okay, so good. I think we are all set. I'm gonna save the file. And in my so I've got, you can't see because it's behind my webcam, but so I've got two bash session here, and I'm gonna request so I need to move all those files into the tutorial folder. That'll be better. I will provide a copy of the output so that you can do it from you can use it. Forgot to save it. There we go. All right, and let's submit a request. There we go. So that should load now. We can go back to our over terminal on the logging node, and I'm just going to reopen the recipe of Australia. Okay, so now next section. Sorry, we need some datasets. So for datasets, we're going to use. I've chosen to use one of the Access ESM 1.5 submitted to CEMIP6. So I'm just going to mention the CEMIP6 project. We're going to look at the monthly atmosphere MIP and the historical experiment. We can define an ensemble. So I do it like I've got another window open you cannot see, so don't worry. I'm not doing this from memory, right? And ensemble R1 E1 P1 F1 using the grid GN, and you can specify like a time range. So starting from, let's say, 1971 to I think, let me check what's available. I can do 2013, for example. Okay, and so that's one data set. Right. Let's save this. So ESMValTool is going to find that that data set for us, but just to quickly show you where it is on Getty. So this is the CEMIP6 ACCESS-ESM publication. So it's in the GData FS38 project. And CEMIP6. So ESMValTool knows about that. That's part of the configuration. So you don't have to worry about this, but I'm just showing you so that we know what we're talking about. So ACCESS-ESM, then we've got, we've just going down the DRS, like CEMIP DRS, and go to historical, and that's where we've got all the ensembles. Okay, and we ask for R1, I1, F1. Okay, and we also ask for Ayman, and that's it, I believe. Right? Okay. All right, so let's just go back to our tutorial. So we've defined like some documentation, like important metadata information, and we've got one data set. For now, we don't have any preprocessors, and we don't have any diagnostics. So preprocessors, you well, you don't need to have preprocessors. You could just use the data directly if it fits your needs. But of course, you need to have you need the diagnostics. So actually, it's not entirely true. I could pass like a null value to diagnostics, but the recipe will do like basically nothing. So which is like kind of useless. All right, I'm going to start with diagnostics now. Okay, so I'm going to create one diagnostic and called Australia monthly temperature. Sorry. We can add some description. Let's say it's going to be about visualizing the monthly temperature for Australia. Okay. And then you need to define some variables you want to process. So again, you name your the variables. I'm just gonna have one, and I'm gonna name it surface temperature. So ESMValTool already knows the dataset we're going to use. It knows that it's from the M1 MIP. So it needs a bit more information to extract the right data, right? So for now, surface temperature, and it's probably going to struggle to find it, but we can pass the name like a short name, TAS, which is from the CMIP vocabulary, so we know where to find it. And for now, we don't have any preprocessor. Okay, so we just tell it where to find the variable. So the diagnostic needs like two things. It needs a set of variables, and it needs some scripts to run. So we're going to use one script called Australia map, and give it a path to a script. And for now, I'm just going to use nil, just for the sake of slowly taking you through like the process of writing. Actually, what I'm going to do is I'm going to put the path to our Python file we've just created. So it has to be the full path. I mean, in development, it's better to use the full path, I think. I've tried to use relative path, but it's not always like behaving as expected. So I think the best way is just to use the full path, and the script is called australia.py. Okay, and just quickly, I'm gonna add the shebang to my Python script, just to make it so that we know it's a Python script. All right. And what I'm going to do next is I'm going to try to run that recipe, which for now doesn't do anything. Okay, so I'm going back to my over terminal, which is now an interactive job on the Q system, and I'm going to load ESMValTool module use. Well, module load ESMValTool. There we go. And I need to I forgot to load to mount TM70. That's okay. Let me fix this quickly. So let's go back to our job PBS, and we need to add Scratch, sorry, TM70. All right, let's save this. And submit the request again. Okay, so now we've got a new interactive session. Sorry about that. Need to reload. ESMValTool. There we go. And we can now move to TM70 tutorial. Alright, so I'm now in the tutorial folder. If I ls, I can see I've got the recipe Australia, my diagnostic script, and the job.pps file that I use to request resources on Getty. So let's go ahead and try to run the recipe Australia, and let's see how it goes. Alright, so like just to show you live, it failed, and it failed for so you need to have a look at the log file. It's always useful and a good exercise. There's a type error here. Argument of type non-type is not iterable, and the reason being so it tells you that something is in preprocessors. So I suspect like the issue is because I don't have any preprocessor defined. So which means that probably we're gonna need to add one. I'd be curious to see what happens if I remove a preprocessor altogether, but just like I'm not gonna do this now because I need the video to be relatively short. So let's move on and add some preprocessors. Okay, so what kind of preprocessor do we need? So we've got a data set with some like a temperature field that we want to use. The idea is to do a map and calculate some climate anomalies. Sorry. And we wanted, and let's do something a bit more advanced. We've defined a range, like time range from 1971 to 2013, but we're just gonna extract 1 year from this. So the example, it's kind of a dummy example because I could just ask for a range here of 1 year range. Okay. But what we want to do is actually we're going to calculate an anomaly. Okay, so we want a broader, like larger time range, because we're going to define a reference period for which we're going to calculate the anomaly for a specific year. Okay, so let's start defining some preprocessor. So I'm just going to do one preprocessor, and I'm going to call it something, can be anything. Okay, let's call it extract data. And what I want to do is I'm going to use one of the preprocessors from ESMValTool that's called anomalies. Right, so anomalies. Maybe we can quickly have a look at the documentation online. So I always have the documentation open when I do this, because well, there's a lot of information available. And let's search for preprocessors. Okay, and I'm going to go to preprocessor function, documentation using material. No, what I want is actually the API. I can actually do a search for preprocessors anomalies, maybe. Here we go. So taking back to preprocessor functions anomalies. So what it does, it computes the anomalies using a mean with a specified granularity, okay? And so it needs a few things. It needs a reference, a period, and of course it takes a cube as an input, but that's done internally, right? So you don't have to worry about that. So you need to define the period, you need to define the reference, and then you've got some optional options like standardize, to standardize the anomalies that are calculated. And there's another season option that we won't use today. Okay. All right, so let's go back to our work. Okay, so anomalies. As I mentioned, it needs a period. It needs a reference. And we're just gonna have, and there's an optional option that is standardized that we're gonna set to false, which I think is the default, right? If I go back to my web page, yes. So period can be anything from like full, season, seasonal, monthly, month, daily, day, hourly, or etc. We're gonna use monthly. Okay. And we need to define a reference. So talking about the reference period here. And so the reference period, again, going back to the documentation. Period of time to use a reference as needed for the extract time preprocessor function. All right, interesting. So that means we need to have a look at the extract time preprocessor and to understand what that preprocessor needs. So it needs a cube. Again, ESMValTool will pass that by default. It needs a start year, start month, start day, end year, end month, end day. All of these being required. All right. Okay, so let's go ahead with this. So start year, start month, start day, and then we've got end year, end month, end day. Okay. So the reference period, we're going to define it over from 1971, 1st of January to the year 2000, last day of the year, like 31st December 2000. Okay. And we've got our preprocessor. Okay. So let's save this. I'm gonna clear the terminal here. All right. And let's try and see how it goes. So just gonna rerun it again, and let's see how it goes. And I just got a file does not exist error because my path is wrong. Path is ESMValTool tutorial. Okay, let's try again. Just clearing this. Here we go. And we have a successful run. Interesting. Good. Okay. So there's no output, obviously, because it's not doing anything. And I'm just going to quickly check my ESMValTool configuration just to check where the tools is storing the output. Oh yeah, so I've predefined it to be in Scratch IQ82. So I'm just going to change this so that we have this is the default. So I like a custom setup from a previous run. And I can actually rerun ESMValTool on our recipe and see what happens. Okay, run successful again. And now if you look at my file explorer there or here, I've got an ESMValTool output folder, and there is an output for recipe Australia with just one folder, a run folder, because well, we haven't done much, right? In that that recipe for now is basically doing nothing. The preprocessor is not called if it's not needed by a diagnostic. So and we haven't listed any preprocessor there, right? But you can see that in the run folder there is like some log information on resource usage, and debug log. There's a copy of the of our recipe, and there's actually a copy with some extra information that ESMValTool is adding for you. Could be just out of curiosity, we can look at what is done. Oh, I can't do that, of course. So if we look at Australia field, yeah, it has completed like the information about surface temperature, and it also has specified the dataset used by our diagnostics, which is the ACCESS-ESM 1.5 here. So this is basically a clean version of our recipe. So it's probably what you would eventually submit if you wanted to submit a pull request to the ESMValTool GitHub repository. All right, let's go back to our recipe. So for now, it's not doing anything, but it's running. Okay, let's just like clean that output. So just quickly to mention that that folder has a tag, a time date. So technically we could just keep it, but it's a bit of a pain just to we don't need it anyway. So what I'm gonna do now, just to illustrate a bit further how things work, I'm gonna add a preprocessor here. Well, I'm gonna explicitly say that I want to use one of the preprocessors that I've defined above, and there's only one, so it's easy. So just calling extract data. So now that it's called, it's specified here, ESMValTool is gonna run the diagnostic, see that it needs to get surface temperature from our dataset there, which is one dataset here, and pass it to the preprocessor extract data, and the preprocessor is going to run it's going to calculate the anomalies, like monthly anomalies, using a reference period from 1971 to 2000. Okay, so let's save this and run it again and see how it goes. All right, success again. Okay, so now I'm using let's have a look at the output. So we've got the recipe Australia, blah, blah, blah. And the interesting thing is that, yeah, so that hasn't done much actually. So it hasn't saved the preprocessor information. Why is that? That's interesting. Okay. One thing it could be, and then we're going to do this live again, is looking at the configure, my configure file. There's an option for preprocessor. Remove preprocessor directory. Okay, it's set to true. All right, so I'm doing it live for you. There's obviously could have avoided this, but I'm just going to set it to false. Clean my folder again, and run ESMValTool. Run again. Right. Okay, so now let's have a look at the output. And now I've got a preprocessor folder. Okay, so let's make this a bit bigger. And so we've got the output for the Australia monthly temperature diagnostics. Totally fine. That called a preprocessor, and yeah, and then in that folder, sorry, here, what's going to happen here is the list of variables. So we've got one variable that we call surface temperature. Let's have a look. And so we have a new netcdf file. It's the output of our preprocessor, some provenance information, and some metadata or YML. So ESMValTool has a great system for provenance. You can open these things and have a look, explore, but it's basically some information that is passed from the preprocessor to the diagnostic script. So I will explain a bit further down the track what this does. But yeah, okay, so our preprocessor is working, which is great. Let's go back now to our recipe. So what I mentioned before is I want to calculate some anomalies. So that first, that preprocessor is going to extract the data and calculate the anomaly, the monthly anomalies using that reference period. But I don't want to pass. This is going to calculate the anomalies for the entire period of our dataset, right? So from 1971 to 2013. So what we want to do is we just want to extract 1 year. So we can add another preprocessor just to extract a specific year. So we've discussed the extract time preprocessor before. It's basically the same as here. So actually I could just copy and paste this to go a bit faster. And what I'm going to say is I just want to extract 1 year. And that year is going to be 2013. So I now have like still one preprocessor, but after like calculating the anomaly, I do I extract 1 year, actually 2013. Here we've got a special case because so ESMValTool has a predefined order in which it runs the preprocessors, and now in our case we kind of want to force it. So I'm gonna use an extra option called custom order and set it to true to force it to be first calculate the anomaly, then extract the year 2030. There's some details you usually don't see this in the recipes, but it's just like something I'm doing here, okay, for the sake of the example. And I believe our recipe is ready to go. The only thing missing is an actual diagnostic because our Python script doesn't do anything. Okay, so I'm gonna pause now and I'll be back to discuss how to write a diagnostic. All right, so we have a recipe that runs and calls some preprocessors if you want. All you will need to do now is to actually create a diagnostic, okay? Because for now diagnostic is not doing anything. There's nothing in our Python file. All right, so as I said, ESMValTool is relatively language agnostic. You can write your diagnostics in Python, R, Julia, NCL language, and there will be options to go further than that actually if needed. But that covers like 99.9% of the needs. Okay, so let's go ahead and let's write our diagnostic, okay? So what do we need? To run the diagnostic, so there's a few things that are needed. We need to import some function from ESMValTool. And one of them is let me see. We need to, at the bare minimum, we need like a way to call the script from Python. So typically that's, I forgot how we call that in Python, but it's a way, so it makes the Python script like directly executable. And you need, you call a function called run diagnostics as config, and you pass it to a main function. So people who know a bit about Python would just like tell me, okay, so what's that run diagnostics diagnostic function? So it's a function that you get from ESMValTool, and there's like basically retrieve information from ESMVal core and the preprocessor. So it's a way to access the metadata and all the details of what's happening in the recipe. Okay, and so it's called from ESMValTool diag scripts shared, and you import run diagnostic. Here we go. And of course what we need here is a main function to call. All right, so let's start with the main function. Typically, the main function will take a configuration as an argument. So I'm just going to call it CFG here just to make it slightly different. And so what we want to do in that function is we want to retrieve the data that ESMValTool is passing to our diagnostic script. And we can retrieve it from the config object, and config object is basically a dictionary, Python dictionary structure, and this is how you access the values, the input data values. All right, so just some clarification about what I'm doing here. If we go to our ESMValTool output folder, which I have deleted, so I'm going to run it again just to generate some outputs. Here we go. Let's go to ESMValTool. If we go in the run folder, you'll see that there's for each diagnostic, so there's a folder, and in that case we only have one diagnostic, so it's called Australian monthly temperature, and Australia map. There's a file called settings.yml, and that file contains basically the information passed to the diagnostic script. And you can see that input file that we're calling from our config dictionary here basically contains path to our pre-processed dataset that are located in the pre-proc folder. It also retrieves information from that pre-proc folder, which also contains some metadata. So I can quickly go there and show you that there's like some metadata there with some information that are also passed to the diagnostic. So all these things you can access basically from the config dictionary here. So that basically tells you how, you need to be aware of that. So that's how you access data. Okay, so I'm getting my input data. So going back to our recipe, we could have several variables here, which means several data sets, like with different, potentially different preprocessor code. So the input data here that is returned when we call that our dictionary is actually a list of outputs. So we want to loop over these. Okay, so I'm just going to quickly write a loop. I'm gonna, so first of all, load the data. Put file equal dataset. So for each dataset I have a file name. Again, you refer, like if you want the detail, you can refer to the settings.oxml file that I just mentioned. So each dataset has a name. You can access a variable group, and the data. So we're going to open the data with Xarray. In that case, we could use something else. go. So I'm just opening the data, which means I need to make sure that I can import X-array. So I'm just gonna add the import statement at the beginning. As XR, here we go. And just for the sake of, I'm gonna call like some standard library, like path library from Python, just to have a bit of. Okay. So I'm looping through the dataset inside the input data that I retrieve from my config object, and I'm extracting the data. That's basically all I'm doing. So now I need to do some something with it. So I'm gonna use matplotlib and call a function called plot Australia that returns a figure object from a matplotlib figure object. And then what I will do is I will save the output to the disk. So I'm just gonna slightly change the name of the input file to create an output. Here we go. So using the name from the variable group. And define an output path. So there's a convenient function that we can get from ESMValTool. Oops, sorry. Diag script shared. It's actually an hidden function, but let's go ahead. Just a way like to. I'm using an example that I've used before. So it just done some. It's just doing a bit of magic here, but that's all right. You just create an output path. You could hardcode it. It's all good. Output file, and it needs to pass the config as well. And we want to save our future matplotlib figure object to that path. Okay. But for now, so I'm gonna plot Australia function that doesn't exist yet, that returns a matplotlib figure object that doesn't exist yet. So let's move on, and we define a plot Australia function, and that's going to return a figure object. Okay. All right. So it's not really. So it's not meant to be a tutorial on how to use matplotlib. So I'm going to cheat a bit here, and I'm just gonna quickly copy and paste a plot function. That I've written before. There you go. And so I will just like suggest you have a look at it when you have time. So basically all the, I mean, it's the recipe on how to write on how to reproduce the figure I've shown at the beginning. And I've got a couple of utility functions that I need to, basically a function to retrieve the polygon for Australia, because in that case I'm doing the masking using Cartopy, and that masking is done by basically subtracting that polygon from a rectangle that covers the map area. So nothing crazy, but I'm happy to answer your question if you need, or you can just look at the code if you need. I'm just gonna add some import statements at the beginning, basically calling some shapefile Python objects, Cartopy to read the shapefiles, and Cartopy to do some projection and plot some maps. Just quickly to mention that here I'm using data from Natural Earth, and this is already available. This is made available through the auxiliary dataset, like that you can access from ESMValTool. No, actually that's not true here in that case. I download it, okay? Which means you need access to the internet from your queue. Yeah. Anyway, so just something to keep in mind. Yes. Okay. All right, and that's basically our diagnostic. So one thing I forgot is that function here needs some argument. All of this is basic Python. Okay. So we pass the data, we pass the name, and we pass a color map. Color map that needs to be defined, by the way. So I'm just going to hard-code it here. But I could pass it from the recipe. So add some options to the script. So how to do that? So I could have like a color map keyword here and pass reds instead. Is it? Oh, it's not. It's cool warm. Sorry, cool warm. Which means I could retrieve this from the I could do something like this, right? Okay. Let's leave it like this for now. All right. So, and I think we're ready to run it. If I haven't done anything wrong. Okay, and so let's just go back to our interactive session. Oh, I'm not in the right folder. Go, let's try. And here we go, we have a successful run. So I go to ESMVal output, and I take the last one, which is 243.15. Just gonna clean the others, delete. Right. We've got some plots hopefully there, and we can have a look. And here's our map. Right. Okay. So what else do we need to do? That's basically it, but just a few things I want to mention. So here in that case, we only have one data set, okay? We could add another one. Let's say we want to use another ensemble. So I'm not sure which ones are available. Let's have a quick look. FS38, semi-published, SEMIP6, semi historical, and we could pick any one of them. Let's say I want to do this one. Right. So now I've got two data sets. So if we run this again, going back to here, we go. So we get another successful run. And looking at the latest one, if we go to plots, we've got now two plots, one for each ensemble. And you notice that they are quite different because the way I'm scaling the color map is different. All right, so something to maybe modify. So that's one thing. If we want to, we could also do, instead of having one variable, we could have multiple variables. So we could have one for, let's say, precipitation. So let's add one for precipitation. Just using exactly the same preprocessor, and just call it precipitation. There we go. We can try that again. Okay, and so this is actually failing, and the reason it's failing is because my script is not general enough. I am calling the task variable somewhere here, so it's failing for precipitation. All right. So it's, yeah. So you get the idea. And you just need to make that script a bit more flexible, which I try to do it and give it to create a repository. But that's the idea. So you could have like multiple datasets here for multiple models. We could have like more preprocessors and use a specific preprocessor for the precipitation. We could have like another diagnostic that is specific to precipitation, which calls the could be the same script, but just with different information, so that the script is responding differently. All sorts of things that are possible. All right. Okay, so this this was just like a walkthrough, like to try to explain how things work. I went like way too fast. I'm aware of that, and the script like is far from being optimal. We could do things a lot better, but you get the idea, and I hope it's been useful. Right, as usual, you can request help on the Hive, on the Access Hive. So I strongly encourage you to do it. And that's pretty much it for today. Thank you very much.